At this point, I expect you may quite naturally want to know the answer to the question, where does spin come from? So we'll try to give some answers to that here. Initially, spin and the mathematical framework of the Pauli spin matrices were postulated simply to explain experimental behavior. Now, it happens that Schrödinger's equation is well known not to be correct under special relativity. It is largely really deduced from non-relativistic mechanics. Dirac was one of the first to look at how we might make quantum mechanics consistent with special relativity. He showed that if one postulated a version of the quantum mechanics of an electron that was correct according to special relativity, in his famous Dirac equation for the electron, the spin behavior of the electron emerged naturally. In the Schrödinger equation, we have a second derivative in space and a first derivative in time. In special relativity, however, it's essential that one treats space and time on a much more equal footing. Essentially, it was not possible to construct a relativistically invariant wave equation that is first order in time and in space, without introducing another degree of freedom in the formulation. And that additional so-called dynamical variable is spin. It's usually stated that spin, therefore, is a relativistic effect. It is, however, only necessary to require that the electron obeys a wave equation that treats time and space only with first derivatives, rather than having time treated as a first derivative and space using a second derivative, as in the Schrödinger equation. If one does that, then the spin behavior emerges. One can therefore construct both relativistic and non-relativistic wave equations that treat time and space both through first derivatives, and which have all of the solutions of the Schrödinger equation as solutions also, but which also naturally incorporate spin. If one takes this approach non-relativistically, one obtains an equation that can also be rewritten as the Pauli equation above. Now, whether we were trying to construct a relativistic or a non-relativistic equation for the electron, simply put, when we postulated Schrödinger's equation, we got it wrong. If we postulate the correct equation, spin emerges naturally as a requirement, and nature tells us we need to incorporate spin for a complete description of the electron. Now, that may not be the kind of explanation you were hoping for. I've merely said that if we put together the right kind of mathematics so that we have an equation that also obeys special relativity, then spin emerges. Essentially, that's about as good a story as we can have. Incidentally, it's also worth noting that when Dirac put together his argument with spin emerging naturally, the same argument also predicted the existence of antiparticles, specifically the positron that is the antiparticle of the electron. That prediction also turned out to be correct. Dirac's equation is quite a remarkable piece of physics.